Alright guys, we are going to do page 101 of your student journal, and we're going to do 7 through 13. You will have a notebook check on Friday and a quiz on Friday on reflections and translations. Okay, let's talk. Alright, so it says in exercises 7 and 8, graph triangle JKL with vertices, these vertices here, and its image after the glide reflection. So a glide reflection is when you perform a translation and then a reflection. This is an example of a sequence of transformations. So the first thing I'm going to do is plot these points that it gave me. So it says 3 and 1, 1, 2, 3, and 1. So this becomes J. And then I'm going to go plot 4 and 2. Oh, I'm making that mistake again. So we need to look at our scales. We need to look at our scales. Our scales here is going by 2s. All right, let me get it together. So actually this is 2. So this is 3 here. And this is 1 about here. All right, that's J. And this is 4 and 2. This is K. And then we get 1 and 3. So 1 and about 3 goes right here, and that's L. So guys, please be careful with this scaling. I think I made that mistake in another video and I had to fix it too. Hold on, I'm trying to connect these dots, guys. Okay, so there we go. That is our pre-image. Now we're going to do what it told us to do, and I'm going to do it in blue with the translation first. This means to go to the left 6 and then down 1. So since I'm going by 2s, I'm going to count in betweens. So this is 1, 2, 3, 4, 5, and 6. And then it says to go down by 1. So this is my L prime. Then it tells me to go J. I need to do the same thing. So 1, 2, 3, 4, 5, and 6, and then down 1. And I'm counting in between the boxes, guys, because this scaling is by 2s. So 1, 2, 3, 4, 5, 6, and then down 1. And that is my K prime. So I performed that translation by sliding. Did it? And now it says a reflection in the line y equals negative x. So if you look here, if this is y equals negative x, I'm lucky. There's a rule that I can make for this. So now all I need to do is get the coordinates for L prime, which is 5 and 2. So negative 5 and 2. K prime is going to be negative 2 and 1. And then J prime is going to be negative 3 and 0. So the rule when I have this, it tells me to switch X and Y and then take opposite signs. So if the sign is positive, you make it negative. If the sign is negative, then you make it positive. Take opposite signs. Alright, so my L double prime would be, if this is 2, then it becomes negative 2. If this is 5, negative 5, it becomes 5. Alright, this one, switch this becomes negative 1. This is 1, so I switch its position and move it to the first one. Negative 1, this is a positive 2, negative 2, so we're going to make it positive, and this is double prime. And then J double prime, switch these two, we get 0, negative 3. 0 is neutral, so it's not negative or positive, and negative 3 becomes positive 3. All right, and the only reason I switched the signs because of that negative right there. And so I'm going to put this one where it belongs. So now we're going to go to negative 2 and down to negative 5, so that goes here. L double prime, and then I'm going to go to -1 and +2. Wait, that looks strange. So this is -2. No, it's right. So this is -1, and we're going to go +2. That is K double prime, and then we go to 0 and 3. So this is 0. That looks strange. I'm going to go back and check. I think I made a mistake. I'll check it in a minute though with L double prime, because this looks strange. And then I should go to 0 and 3, which is about right here. And that's my J double prime. I made a mistake somewhere. So let me go look at my L prime. This is -5 and then up 2. All right. So here, this should be switching X and Y. I should switch them and change the sign. So this should become -2, +5. Oh, now we know where we messed up at. I plotted it at -2 and -5. So here's how I'm able to pick up on my mistake. I knew a mistake was happening because these are rigid transformations. So that means the shape of the picture should not change at all. And I noticed the shape was going to change. That's how I was able to pick up on my mistake. Those are things you can do too, guys. So we all make mistakes, and I'm showing you how you can go back and correct them. So you have to understand your information. That's how I was able to pick it up. That point didn't belong down there. It belonged somewhere up here to keep the shape the same. So now that's -2 and 5, and that's called error analysis, what we just did. And that's L double prime. And here is the, hold on, let me make that look a little neater. That is your final picture. And here we performed a glide reflection. Well, we did a translation and then a reflection. That's called a glide reflection. Okay, let's go ahead and go to number 8. So let's go ahead and plot these points again. Well, we have 3 and 1, and this is going by 2, so 3 goes about right here and 1 goes here. That is my J. Then we're going to go plot 4 and 2, so 4 and 2, that's my K. I don't like when the scales are squeezed like this because it squeezes the picture. And then here I'm going to go 1 and 3, but hey, gotta work with it. And that is our L. Okay, so we put that on there, and this time this tells me with the translation to go nowhere with the X, but we're going to go down 4. All right, so let me get that first image, nowhere with the X, but we want to take all of them down 4. So this is 1, 2, 3, 4, and I'm counting in between because this is going by 2s. So this is my J prime. 1, 2, 3, 4. This is my K prime, and then 1, 2, 3, and 4. And this is my L prime. All right. Now next it says reflect in the line X equals Y. So I don't have any special rule for this one. So we're just going to have to draw the line of reflection and count. So my line of reflection is going to be, I'm going to make it a dotted line so you can clearly see it. And it says that X equals 1. So here is where X is equal to 1 at. And I'm going to draw a line straight through that. And let me change that color. So I'm going to make it light blue. Oops, hold on, give me a sec. Got it now. And is it light blue? Yes, it is. All right, so here's where X equals 1 at, and it says in this line. And that's my line of reflection. So this is X equals 1. Okay, and I'm going from the prime one. Oh, and where did I make a mistake? Once again, that is not x equals 1. That is x equals 2. So we need to move this. We need to move this line to where x is equal to 1 at. So hopefully you're writing with pencils, and this is normal. If they change the scaling, you have to catch it. Alright, so x is 1 equals 1 is in between here. In between 0 and this mark is actually 2. Now, the thing that'll help you, if you label these scales, then you won't get it wrong. I hadn't labeled mine, so I'm making a lot of mistakes. But you're getting to see error analysis here. And you can just go back and fix it. Alright, so that's my line at x equals 1. It goes through this point here. So I need to reflect this image here, and if you notice, L and L double prime are going to be the same because that point is sitting on the line. So if it sits on the line, it doesn't change. Alright, but I do have J prime that I need to reflect across this line. So that's 1, 2. So I'm going to go over 1, 2. And that becomes my J double prime. And then K is going to be 1, 2, 3. So we're going to go 1, 2, and 3. And so this becomes my K double prime right here. And connect the dots. And if you notice, the primes and the double prime pictures should match up if you fold your paper across this line. And there you go. I do believe, no, I don't think we're finished. I think we had to do all the way up to 13. Let's go see. So we're done with those two. Yeah. Okay, so 9 through 12 tells you identify the line of symmetry of the word. Now, the difference between a line of reflection and a line of symmetry is that the line of symmetry actually is on the picture. It's on the picture. So we're going to look and see if this figure has any lines of symmetry. If I put it down the middle, it doesn't have any, but I can slide it somewhere across here. And it has it. So it has a line of symmetry going that way. Alright, this next figure, if I go this way, then when I fold it, it doesn't match. But if I go straight down that 0 or that O, then they match on both sides. Alright, the word kid, if I go straight down the middle, it doesn't work. If I go diagonal, it doesn't work. But if I go across, and I'm going to slide this down. There we go. And then for the word dock, if I go down the middle, I don't have one. But if I go this way, if I go across there, I have my line of symmetry. And we good. And of course, you know, you can make your line straight so that it fits. And we're done with that. So let's go ahead and go to 13, and then we'll call it quits. It says if you are placing a power strip along a wall W that connects two computers, where should you place the power strip to minimize the length of the connecting cables? Okay, so where do you want to put the power strip? So I'm going to play with this. If I put the power strip right here, if I put it right here, then that means I would go here and I would end up going here. Alright, if I put the power strip, let's see, where else can we put the power strip? I don't think that's minimizing it. Here's what I think. If I put the power strip somewhere along this line right here, I think this would minimize the amount of cable I have to have. Because here's what I do know. The distance between 2 points, the diagonal distance between 2 points, is always shorter than going from here to here. It's always shorter. And how to say, you're placing power strip along W so that you can get the least amount of cable going. So I would say that if I go diagonal like this and I put that power strip somewhere along this line, then that's the shortest amount of space I could possibly have. That's what I'm thinking. So if I put it right here, then I have to connect from here, then I have to go down and connect from here. Or, oh, look, I could go from here to here. This seems to be the shorter distance too. Well, no, not from that direction. So I'm thinking as long as we have it somewhere along this diagonal line, that's going to be the shortest distance. That's my take on it. Because what I do understand is the diagonal distance between 2 points is shorter than going here and then here. It's shorter than going from here to here and then from here to here. I think this diagonal distance would be the shortest. That's just my opinion about it. You write what you think, and for here, there's no right or wrong answer. Okay, I will see you guys in class tomorrow. Bye.